At the Global Climate Conference in Paris in 2015, 195 countries actually signed a contract to limit global warming by 2 degrees. To reach that goal, also agriculture needs to contribute to the reduction of emissions. Unfortunately, most of the processes which create emissions from agriculture are tied to biological processes which cannot be changed. But there are 2 low-hanging fruits that can be tackled relatively easily, and this is the diesel consumption and a better use of nitrogen fertilizer in the fields. Today's situation in Norwegian agriculture is actually more or less that farmers tend to use large diesel tractors and apply fertilizer on a uniform level across the field. But with sustainable energy production and the shift from diesel to electrical machinery, we might reduce some of the greenhouse gases which come from the emission of the heavy use of diesel. Another part is that we could also improve fertilization practice by gathering more knowledge about the field and then applying fertilizer according to the plant's needs on a higher spatio-temporal level.
In work package 3, we performed a series of field trials in wheat and barley where we applied various fertilizer rates. Biomass from the experimental plots was collected to reference the measurements taken by a hyperspectral camera mounted on our unmanned aerial vehicle or a drone using an agronomic nitrogen distribution models that varies the nitrogen application according to the variation of the biomass density and nitrogen uptake in the field. We converted the biomass map into a map of application rate.
Når vi skal lage en tildelingsfil med høy romslig oppløsning, velger vi å bruke droner som flyr over åkeren og tar bilder med avansert sensorikk på. Disse bildene syr vi da sammen til å bli et stort flybilde, som vi i senere tid kan prosessere innendørs, og da enten finne en måte å estimere biomasseinnhold på plantene, hvor mye nitrogen de tar opp. Dette kan vi igjen da bruke til å lage en tildelingsfil til traktor, som den da kan bruke utendørs for å gi gjødsel på et høyt oppløst nivå. Når det kommer til hvor mye gjødsel som er på et jorde og behovet for gjødsel hos de forskjellige plantene, så kan det være en relativt stor forskjell. I de tilfellene vi har testet ut, så har vi jo kjørt det som kalles for en normgjødsling. Altså vi gir en flat mengde på 6 kilo nitrogen, som vi deretter deler opp og ned med 3 kilo forskjell. Så i det tilfellet her da, rent praktisk, så sier vi da at da har vi 9 kilo behov på enkelte områder på jordet, mens andre steder hvor det allerede er mye næring i jorda, har vi bare gitt 3 kilo nitrogen.
One of the main goals of SolarFarm is to replace this diesel-based tractor with electrical ones. But when we think about the same power consumption or the same power capabilities of the diesel tractors, then it will be, with today's technologies, when it comes to batteries, it will be unfeasible because the battery's weight will be too heavy for the tractor and the tractor will actually damage the soil. So one of the ideas that we want to explore during the SolarFarm project is to actually use smaller electrical tractors instead of using one big electrical one. But then another problem comes into the picture. The problem is how to drive these tractors. There is this solution that we have 3 drivers for the tractor, which is not appealing for the farmer. It's not a good solution. So one of the ideas is that we have one manned electrical tractor and the two others follows autonomously. So there will be like one leader and two followers. What we see here is the mobile charging station that we put in place for charging our fleet of vehicles. The idea is that we want to have one mobile charging station for all the vehicles and not one charging station for each vehicle. So what we see here, we have an industrial arm that is placed on a mobile station. It means that the whole charging station can actually move freely inside the garage and then goes from one vehicle to the other vehicle to charge them, and then plug the cable from the wall to the vehicle exactly as a human being would do.
Bakteppet for prosjektet var å bidra til å redusere utslipp av klimagasser fra jordbruket ved å optimalisere bruk av mineralgjødsel og å finne alternative energikilder til fossilt drivstoff for maskinparken i jordbruket. Vi har vist at konseptet vi har jobbet med i prosjektet fungerer, og at det faktisk bidrar til reduserte klimagassutslipp. Dette kan derfor være en av flere mulige veier å utforske for å finne fram til et mer bærekraftig jordbruk.